All right, we're back doing derivatives. Why not? I mean, I can't think of anything better to do this summer than do derivatives, right? So let's do it. All right, we got this one, which is a different, I guess it's not the summer anymore. When you're looking at this, it won't be the summer. But just remember, back to the summer stuff. T-shirt, relaxing. It's actually very hot in this room because I'm all indoors, soundproof. No, that's lying. That's not soundproof. All right, here we go. Derivative, 2 over t, I'm going to use definition. All right? So when we use the definition, I wanted to show you some crazy fraction action. So we're going to get 2 over t plus delta t, then minus 2 over t, all over delta t. That's how we would use the definition. Now, as Shipdog would say, or shipping, you're going to butterfly this somehow. I don't really know how that works. I just get a common denominator. I multiply this side by t and t, which is equivalent to 1, and I multiply this side by t plus delta t and t plus delta t. Nice, nice. So now I'm going to get, when all that smoke clears, I'm going to get the limit as delta t approaches c. Approaching c? It's approaching 0, folks. That's what the definition says. Approach 0, no c. All right. As it approaches 0, I'm going to do a lot here. I'm going to have 2t up top minus 2t plus 2 delta t. All over that big product. T plus delta t. All over delta t. So not too shabby. All right, gets a little algebra intense, but this is a Marashio hint. These guys, anytime you have a fraction over a fraction denominator, the bottom one just comes up and joins together with the band. Hey, that's a song. Do you know who sung it? I know I didn't do a great job, but join together with the band. All right, British group. Find out. Google it. Danny Ortiz, if you're in the class, Google it. All right, so these two are going to join together with the band, and you're going to get the limit as delta t approaches 0 of up top. Let's cancel like terms and just get 2 delta t's over this monstrosity of delta t times t times t plus delta t. Well, this is all a factor on the bottom. If it's all a factor, I can do some canceling. I can do this. They cancel. So I'm just left with the limit. I like changing colors too. Not screw you up, but just to kind of make it look a little exciting. 2 over t times t plus delta t. We are going to take this to the limit. Another band. Who? American band. You should know it. Look it up. This goes to 0, and I'm left with 2 over t squared. Or if you wanted to get silly and crazy, that's 2 to the t minus 2 power. Either way, there is your derivative. And that's how fraction action, or I should say in the math terms, mixed fractions, are taken care of in this derivative or algebra sense. I have another problem that I'm going to ask you on a quiz either tomorrow or the next day. And it looks like this. Find the equation of a that's equation. That's my shorthand for equation. I'm just moving a little bit here. Look at the sweat. Jeez. Find the equation of a tangent line to f of x. We got a little cut off here, so let's make it nice. F of x equals x squared plus 1. And it's going to be at 2, 5. So we're going to go through our definition. I think we've done this one before almost. The limit is delta x approaches 0 of x plus delta x squared, quantity squared I should say, plus 1 minus x squared, I'll put that in, plus 1, all over delta x. I'm not going to do it because I know we've done this before, because the answer turns out to be 2x. All right? So now I have to find the equation of tangent line. That means a y and an x. So I'm going to use the point slope form of a line. And I'm going to say, all right, well, y minus the y value equals the slope, but at that point. So wait a minute. The point was 2, so I'm going to plug in 2. So the slope at that point is 4. So equals 4 the slope times x minus the x value. You're done. That's it. This is good. On my quiz, on AP exams, this is great. All right, that's fine. If you don't like seeing it like that, sometimes they play around with the answers. So you might want to say y equals 4x. This would be 4 times 2 is negative 8. Move the 5 over, plus 5. So you've got 4x minus 3. And that is the equation of the tangent line at that point. Excellent. Something you should be able to find all the time. All right, and it's asked a lot. Next, just some notes here. Differentiability and continuity. Here's an alternate form of derivative that we're going to use to see what's going on with the derivative and continuous functions. And I actually wind up using this a lot, especially in tables on the free response questions. It's f of x minus f of c all over x minus c, limit as x goes to c. Now the limit must exist to use this form of the derivative. It must exist. If you don't know if the limit exists, don't use this. I show you that you check the left and the right. Ooh, excuse me. You check the left and the right. If the left and the right are equal, we're good to go. You could check on an interval. If you check the interval, check A coming through positive numbers, check B coming through negative numbers. They exist. You are, with an arrow, differentiable. Enough said about all the mumbo-jumbo here. Let's see it in action. I don't blame you. Here is a function, a crazy little function. It's called the step function, or the greatest integer function. I think you remember the greatest integer function will look like this. I think, right? It kind of steps up like that. That's why it's called a step function. Well, when I go and do this, and I try to find out if this is differentiable at 0, okay? Looking at the derivative at 0. That means at that point. I have to check 0. So I'm going to check limit as x approaches 0 from the left of the function minus the function is c all over x minus c. Well, using that alternative form of the derivative, I find that the limit as x approaches 0 from the left is going to be that step function, okay, which I don't know if I did a great job there, minus 0, x minus 0, and I get, well, coming through negative numbers, it doesn't exist. So we get infinity, and this does not exist, which makes me think that it's not going to be differentiable. Right there, I probably can tell it's not going to be differentiable. But let me just try and show you the other way, from the right. And let me show you what it looks like. Because you never know when you have to explain some of this stuff. All right, I didn't write there. I started from here. So this x minus 0, since I'm going through right numbers, it would go this way, and it would approach a number. Okay, it would approach a number, and this would be 0. Okay, and so it's still not differentiable. No matter which way, I'm going to abbreviate that, but no matter how you slice it, it's not differentiable. And I don't think you guys have a problem with that. Remember, I look at math graphically. So if you look at the graph, the steps, it's not continuous, it's probably not differentiable. All right? Let's look at something like absolute value. That guy's continuous. Okay, did you like that? All right, so the V, if you will. V for victory. So, here we go. We're going to look at the action is happening at 2. So we're going to look at the limit as x approaches 2 of this baby. And I'm going to look at the limit as, and you're going to have, this is one that I will test you on, definitely. And I'm going to look at where the action's at. All right, set this equal to 0, solve it, and that tells you where the action's at. So limit as 2 from the right, I get the absolute value, or I get the positive minus 0 all over x minus 2. Well, guess what? That's 1. X minus 2 over x minus 2 is equal to 1. So far, we're good. Let's look at the limit as x approaches 2 from the left. Now, using the definition of absolute value, Remember, absolute value of 5 is 5. The absolute value of negative 5 is the opposite of negative 5, which is 5. So it's the opposite of this. So I get negative 1 times x minus 2 minus 0 all over x minus, I think it's x minus 2. Oh, no. There we go. So I get negative 1. Well, guess what? The limits exist from both sides, but they're not equal. So the limit as x approaches 2 of this function, of this absolute value function, does not exist. Because from the right, it's 1. From the left, it's negative 1. So therefore, learning another one. Therefore, not differentiable. I swear to you, I don't make these symbols up. These symbols are in every area. All right? So, now, we're going to take a look at this function. Where's the action at? The action's at 0. All right? That's where I have a problem, at 0. So let's check it out. The limit, I would tell you that. By the way, in the problem, it would say at x equals 0. So let's put that in green, because otherwise it could be anywhere. So the limit as x approaches 0 of this all over x minus 0, we get the limit as x approaches 0 of 1 over x to the 2/3 power. Remember, this is 1, 2/3, you get it. Subtract 1/3 from the bottom, you're good. Now, wait a minute. You know this. Look at the graph. All right? Bottom's getting really small. Fraction's getting very large. This is infinity, or does not exist, whatever you want to call it. Therefore, that was a drum roll. It's not differentiable. And these two problems, both of these, you know them. Absolute value and the 1/3 power. Okay? You might not know the graph of the 1/3 power, but both are continuous. Both are continuous, but not differentiable. That's important. I hope I spelled it right. I hope my face is not in the way there. All right? So we have, here, I'll move it. Look at this. This is pretty cool, I think. I think you'll like this. I'll just move it so my face is nice over here. Both are continuous, okay, but not differentiable. That's important, and that leads me to my next slide. My next slide says if f is differentiable at a point, then it's continuous. Boom! However, the converse, no good. Converse, no good. If you are continuous, it doesn't necessarily mean you're differentiable. Look at the v. Look at the cube root. Okay? Here are some things to also note when talking about continuity and whether derivative is okay or not. The derivative doesn't exist at a point at which the graph has a sharp turn, a cusp, or points of discontinuity. If you look, the first two, here's your absolute value graph. Here's a sharp turn, okay? Here's a cusp. The cusp we call the seagull, okay, because it looks like a seagull. If you drew a seagull back in 3rd grade like I did, it looked like that. Or even now, when I'm 40 plus, I'll draw a seagull like that. And points of discontinuity has a jump. Derivative doesn't exist there. Doesn't exist at those points. Remember, the derivative can exist here, 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 but at these points, those are your problems. Those are your point problems. Remember, you got a quiz tomorrow, okay? I'm recording this in the summer, so it could be on, it could be off a day or whatever. But I'm thinking a quiz tomorrow, all right? Hopefully you got a lot out of this, and I'll see you tomorrow.